This building is part of the Commercial Building Electrical Design Series. We're dealing with lighting design, and we're looking at fluorescent fixtures today. Just taking quick stock where we are. We've gone over terms and definitions involved with lighting design. Now we're starting to look at different types of sources, and again, focusing today on fluorescence. Fluorescent lighting is still a common form of lighting used in commercial applications today. The basic explanation of this form of lighting is that you basically excite a gas by running current through it such that it illuminates. It is far more economical than incandescent lighting due to its efficient form of lighting. There are some design issues that we need to be aware of with this type of lighting. We'll take a look at here in just a minute. With fluorescent lighting, we have a tube filled with mercury vapor that we excite by passing current through it at a very high frequency. You need to keep in mind that this mercury vapor is very hazardous, and you should take caution when removing these bulbs because you don't want to break a lot of them because it could be toxic. And this high frequency is produced by the ballast, which is a part of the luminaire. This causes the gas to illuminate an ultraviolet light. Remember that we can't see ultraviolet light, so the tube is coated with a phosphorus coating that is made to glow by this ultraviolet light. This is actually what we see as light coming from the fixture. I do need to take note, though, that it requires a starter to spike the voltage to ionize the mercury atoms before the arc strike in the tube. This can cause a delay in the fixture turning on. So here's kind of a graph of what happens. And so we close the switch, and it has to build up a voltage here, and then the starter closes and causes the arc across the bulb. Due to the need for the mercury to be ionized and the need for a starter, there are different ways to accomplish this, which results in different types of this type of fixture. Some of these different types are instant start, or you can have rapid start, you can have quick start, or you can have program start. Much of this was remedied with the transition from a magnetic ballast to an electronic ballast, and so we've almost moved totally to program start. But you still can get the other types, and it depends on there's a difference in instant, rapid, and quick, and you pay a different price for those. But fluorescent fixtures are still very sensitive to temperature, in that they do not typically perform well in low temperature situations. You can get them rated for the lower temperatures, but in general, it's not considered a good idea to use them in low temperature applications. Fluorescent fixtures have also experienced a bit of an evolution in the bulb types. The original, most common, was the T12 type. Then somewhere in the around 1980s or so, started transitioning to electronic ballasts and T8 bulbs, and then they went to T5s, which were more efficient. And finally, we see these compact fluorescent bulbs that you see in the can lights. The T designation simply tells us that it is a tubular type bulb, and as before, the number is the diameter of the bulb in the number of eighths of inches. So a T8 would be 1 inch in diameter. And so here's a picture kind of depicting that. You can see the different T-type tube bulbs here, and the coils, and then twin tubes, triple tubes, compact fluorescents, and all that. Fluorescent lighting is still used as a lighting source in commercial applications, but it does have some issues that the designer should be aware of and take into account when specifying this type of lighting. Some of these issues and their impact are going to be discussed in this video. One of the major advantages that fluorescent has over incandescent lighting is that it is much more economical to operate these types of fixtures. The initial installation cost of a fluorescent lighting fixture is usually a little more expensive than incandescent. However, the cost to operate the fixture in terms of lumen per watt is typically much less. The typical efficacy values for this type of luminaire is in the range of 50 to 100, so it'll pay for itself and more in the long run. Another attribute of fluorescent lighting, at least compared to incandescent lighting, is that the lamp life is significantly longer, usually in the order of 10 times longer. This being the case, fluorescent lamps are usually considered in the category of high lamp life. Typical lamp life for this type of luminaire is in the 10 to 24 miles an hour range. Fluorescent fixtures will experience some depreciation from all the factors contributing to the light loss factor, including ballast factor, the light dirt depreciation, and light loss depreciation. The typical LLF for this type of luminaire in a clean commercial environment at least is around 80%. The spectral power distribution for a fluorescent fixture is relatively good in that there is decent coverage in the green, yellow, and red spectrums, as you can see in the graph here. The spectrum for fluorescent fixtures can vary significantly based on the type of bulb luminaire that is specified. These type of fixtures generally provide a good spectrum for most commercial applications and uses. It should be noted that because of the way these fixtures operate, there is an element of UV light that can leak from the bulb. Remember, it generates UV light that illuminates the phosphorus. So that being the case, you have to be careful because this light can bleach or wash out various things such as textiles or art. So that being the case, in an art museum, fluorescent lighting is usually a bad choice because it can damage the artwork over a long period of time. There are many factors involved in determining a coefficient of utilization for a fixture in a given situation, where some of the factors are dependent on the luminaire and others are not. The elements dependent on the luminaire involved in this calculation for these types of sources are generally considered to be good. Other issues of interest related to different sources are that of control, that is warm up, restart, dimming, etc. Due to the need to have a starter, there are issues involved with starting fluorescent fixtures, especially in cold weather. Also, as far as dimming, fluorescent fixtures can be equipped with dimmable ballast. However, many times these ballasts are noisy and sometimes do not work as desired. The final thing worth noting is that fluorescent fixtures do not like to be turned on an awful lot. Therefore, they're not the greatest choice when using occupancy sensors, especially when you're going to have a lot of turn on and off, like in an office or something like that. You have to be careful. Fluorescent lighting is generally considered a very good option for most commercial applications, and it is a very economical choice when applied correctly. That being said, there are some constraints that the designer needs to be aware of, such as low temperature applications and how the fixture is expected to be used or controlled. Dimming these types of fixtures is not always ideal, but the technology is getting better.